All right, welcome back, Algebra 2 students. This is Chapter 1, Section 7, and it's entitled Solve Absolute Value Equations. So the definition for absolute value is the distance a given number is from 0. So that's why the absolute value of 3 is 3, because on a number line, 0, it's 3 units away from 0. That's why the absolute value of negative 3 is 3, because negative 3 is still 3 units from 0. Extraneous solutions are solutions that you find so they're solutions that do not work. What will happen is sometimes you'll get two solutions and you'll plug them in, you'll check the solution, but it doesn't work. And you'll see some situations like that during the note-taking guide and during this video. So, interpreting absolute value equations, meaning the distance between x and 0 is k. That means if x is a positive x, it's k. If it's negative x, it's still k. So, solutions. X minus 0 equals negative k, or x minus 0 equals k. So x is either negative k or k. It can be either or. Here, x minus b, the absolute value of x minus b equals k. It's the distance between x and b is still k. So x minus b should be negative k, which means then the solution is actually b minus k, and over here it would be b plus k. Basically what you're doing, you'll see an example of this, but the absolute value of x, if it were to equal 3, that means x could either be 3 or negative 3. So you write the answer as x equals 3 or x equals negative 3. Those are the two solutions. If you had the absolute value of x plus 1 equals 3, that means this whole thing here can either be 3 or negative 3. So you'd write out two equations. You'd write out two equations. X plus 1 equals 3, or x plus 1 equals negative 3. And then you go ahead and you would solve by minusing 1 both sides. X is 2, or x is negative 4. So you're going to see, you'll see lots of examples in just a few minutes, but let's plug in both of these numbers to check. Let's check 2. The absolute value of 2 plus 1 equals 3. The absolute value, that's the absolute value of 3 equals 3. So 3 equals 3, you are correct. Now the other way, negative 4 plus 1 should give us negative 3. So negative 4 plus 1, all right, that's negative 3. Is negative 3. But then you get 3 equals negative 3. Does that work? This one here is extraneous. All right, so you're going to see lots of examples of this tonight. So here we go. Solve this equation. Pause it, try it if you want. You've done one like this. So try it and see if you can do it. If not, here you go. So just like before, this right here can either equal 6 or negative 6. So you add 3 to both sides. X is equal to 9, or x is equal to negative 3. So x is 9 or x is negative 3. So the solutions are negative 9, negative 3. These are the values, x, that are 6 units away from on a number line. This time it might not be. It's 6 units away from 3. So you would plot the points negative 9. Oh, not negative 9. 9. Right here. And negative 3. And here's 3. And you should see that this is 6 units. And that's 6 units. So this is how this is set up. All right, here's a checkpoint. It's pretty straightforward. What are the two values of x that can equal 5? Well, you know the absolute value of 5 is 5, or the absolute value of negative 5 is 5. So your solutions are at negative 5 and at 5. Here, set up the exact same way. What's inside the absolute values is equal to 2, or it's equal to negative 2. So add 5 to both sides, and you end up with x equals 2 plus 5 is 7, or x is equal to 3. There's 7, there's 3. If you look at number 5, you are actually 2 units away from 5. All right, solving an absolute value equation. So if you have an equation, just like we did here, I'm not sure why the steps are here, write two equations, ax plus b equals c, or ax plus b equals the opposite of c. Then you solve each equation, and then you check each solution in the original absolute value equation. And you just plug it right back in. So, here's an equation. Step 1 says to write two equations where it's equal to the positive right side or the negative right side. Expressions can equal c or negative c according to step 1. Step 2 says to solve. So you're going to subtract 4x from both sides. That's going to give you 2x, or it's going to give you 10x. You divide by 2. X is either 5 or x. Here you divide by negative 10. 5 or negative 1. So check these. We're supposed to check these solutions. Alrighty, so we had the absolute value of 4x plus 10 equaled 6x. So let's check 5. That would be the absolute value of 4 times 5 plus 10 should equal 6 times 5. Well, that's 20 plus 10. Absolute value of 30 should be 30. Does 30 equal 30? It does. So 5 is a solution. Then we check x equals negative 1. Okay, I kind of ran out of room here, so just a minute. So absolute value of 4 times negative 1 plus 10 should equal 6 times negative 1. All right, 4 times negative 1, negative 4, plus 10, that's 6. The absolute value of 6 should equal negative 6. Does 6 equal negative 6? And the answer is no. Therefore, negative 1 is not a solution. So pause the video. Follow the example over here that you just watched. It should still be on the screen. And try to solve number 3 and number 4 on your own. And if you can't watch it, just keep watching. And here we go. So first start off 2x plus 5 equals 11, or 2x plus 5 equals negative 11. Subtract 5, 2x equals 6, x equals 3 is one of my solutions. 2x equals negative 16, so x equals negative 8. Now, if you plug these answers back into the equation, into the original equation, 2x plus 5 equals 11. 2 times 3 is 6, plus 5 is 11. Absolute value of 11 is 11. Yep. 2 times negative 8 is negative 16, plus 5 is negative 11. Absolute value of that is 11. Both solutions work. Let's try out number 4. I'm going to run out of room. Oh, let me change colors here. All right, so 3x. Said I was going to change color. X. So, or, I'll have to do it down here, but or 3x plus 18 equals negative 6x. So, subtract 18. Oh, no. Subtract 3x this time from both sides. 18 equals 3x. That means x equals 6. Down here, it becomes 18 equals negative 9x. Divide by negative 9. X is negative 2. So our two solutions are 6 or negative 2. Now check both of those on your own. I don't want the video to take too long, so you put in 3x. Let's see. 3 times 6 is 18. 18 plus 18 is 36. 6 times 6 is 36 equals 36. This is a solution. Negative 2. 3 times negative 2 is negative 6. Plus 18 is, see, negative 6. Plus 18 is negative, no, it's 12. 6, that's negative 12. 12 does not equal negative 12, so that is not a solution. All right, we're going to not do guided practice 1. You need to do it. I'm going to take a look at number 3. It's the absolute value of x plus 2 equals 7. So in this situation, x plus 2 equals 7, or x plus 2 equals the opposite of 7, so negative 7. So we subtract 2 from both sides. So x is either 5 or x equals negative 9. So if we work this out, throw in a 5 in there, 5 plus 2. 5 plus 2 is 7. The absolute value of 7 is 7. So this works. So you put in a negative 9. Negative 9 plus 2 is negative 7. The absolute value of negative 7 is 7. So it works. Number 5. The absolute value of 4x minus 1 equals 2x plus 9. Now this looks hard, but it's really pretty much the exact same process. 4x minus 1 equals 2x plus 9. Or 4x minus 1 equals the opposite of this. Now the opposite of this would be the negative 2x plus 9 like this. So this ends up negating the 2x and the 9. So add 2x to both sides. Add 1 to both sides. Negative 4/3. Up top, it's a little more straightforward. Minus 2x. Add 1. So your two possible solutions are 5, negative 4/3. So plug both of those back in and see if one of them is extraneous. And when you plug it in, this works. This does not. So that's if it's an equation. Now let's take a look at it as if it were an inequality. If the inequality is less than you rewrite it like this. It's a between statement. You can see that the inequalities are exactly the same. But you write C on the right and negative C on the left. Here, this is greater than. So you rewrite it exactly the same way, or you rewrite it by flipping both inequalities. Now, I'll explain that in a minute. So we're looking at a type. So this is, we'll say is type 1. We'll say this is type 2. We're looking at a type 2 equation here because it is greater than. So the first thing you need to do, and actually let's go ahead and add these to your notes. For these, first thing, determine type. If type 1, if it's type 1, it's a between statement. And it's between with same inequalities but opposite signs. So you put it between with the same inequalities but opposite signs. If type 2, it's an outside. It's an outside equation. You basically rewrite once with no change. So you rewrite it once without any change. And then you rewrite again, but you change the inequality and the sign. So let's just use this example over here. So if you have ax plus b is greater than or equal to c, step one, if you go back up here, sorry, not step one. Step one was to know what type. Well, it's type 2. So it's an outside. You rewrite once with no change. So rewriting it with no change is ax plus b greater than or equal to c. Or you rewrite it again, but change the inequality and the sign. So you rewrite ax plus b, but you change the inequality and you change the sign. That's what this is right there. So let's take a look. Rewrite, this is type 2. So you rewrite it exactly the way, or you flip the inequality and change the sign. Minus 5 from both sides. Minus 5. Divide by 2. Divide each side by 2. The solutions are all real numbers less than 2, negative 2, or greater than 2. So here's negative 2. Here's 2. Greater than, less than. Oops. Somehow messed the video up here a little bit. All right. All right. Like I said, I don't want the videos to take too long today, so let's. It's already 22 minutes in, so graph the solution. Write the inequality. It's a type 1, so it's between, and all you do is you put one positive on the right, negative on the left. Add 1.5 to both sides. Solution is between negative 3 and 6. And it says inclusive because it's equal to. So it is a solid dot. So negative 3, 6, and it's everything in between. All right, here's another one. This is a greater than, so it's type 2. So you're going to rewrite it exactly the way it's written. And then you're going to say or, and you're going to rewrite it with the opposite inequality with the opposite sign. So add 2 to both sides, you get x is greater than or equal to 9. Or x is less than or equal to less than or equal to negative 5. Negative 5. All right. So it's an outside equation, so you've got a negative 5. It's inclusive. You've got a 9. It's inclusive. We're greater than 9. We're less than negative 5. All right, here's another equation. This is a type 1. So you got 4x. So type 1s are between statements. That means you got negative 9 on the left. All the inequalities are the same. Add 1 to both sides. We added 1, it's 10. Divide by 4, and x is now between -2 less than, see here, 10/4, 5/2. Plot the points at -2, circle, because there's no equal to. 5/2 is 2.5, and it's everything in between that. So I could pick any number inside here. I could pick 0. 4x, 4 times 0 is 0, minus 1 is -1, absolute value is -1 is 1, 1 is less than 9. Alright, I don't want this video to go too long, so we'll do a lot of these in class, but practice problems 1.7, these we will do in class. You just do all of the guided practices.